In this video, we'll discuss simple interest. Now, interest is a fee paid for the use of money for a given time. That could be borrowed money or it could be invested money. When we talk about the principal, which is another key term within interest, that's that original amount that is either borrowed or invested. So someone, whenever money is exchanged, is often getting some form of interest. Now, one of the easiest ones to calculate is called the simple interest. And this is interest that's paid in each time period based on the principal. So we use a very basic formula to determine that interest that's accumulated. And it is that I equals P times R times T. Now, what does each of those terms mean? I is for the interest that's accrued during the term of the investment or the borrow. P is our principal, that original amount. R will be the interest rate provided, and that needs to be converted from a percent to a decimal. And remember, we do that by dividing by 100. Time is the number of periods in which the interest is paid. Now, this is a very important one to pay attention to because we need to look at how exactly the interest is being calculated. Most of the time, it will be calculated annually, but sometimes it may be calculated monthly or even quarterly. Sometimes it may also be calculated annually, but you're given months, so you have to convert your months to years to make that work, or vice versa. So always pay attention to how the time is being calculated and make sure that the numbers you have match with that time. Let's look at a few examples. Say that Janae borrows $2,300 from the bank and pays an annual interest rate of 4.5% for 5 years. How much will Janae end up paying in interest on the loan? So first we start with our interest. Here it says how much will she pay, so that's our unknown piece of this formula in this case. The next, let's look for the principal. It says she borrowed $2,300, so there is where we start. The interest rate is our percentage, in this case 4.5%, but remember we have to write as a decimal, so we divide by 100. And last is the time. So I look for that key term. They use the word annual interest. So I know I'm calculating time as an annual method and it's being done over 5 years. So I can put that T equals 5. With my P, my R, and my T, I can now calculate how much interest Janae will end up paying. So 2,300 times 45 thousandths times 5. Follow my order of operations and I multiply left to right. Then I have $103.50 times 5, which will be $517.50. So that means that for this loan, over the 5 years, Janae will pay $517.50 in interest for this loan. What if you wanted to calculate time instead? We can still calculate it, we just have to have different information. So whenever we have a simple interest problem, we'll get 3 of the 4 items and we solve for the missing quantity. So say Daniel places $5,000 in a savings account earning 3.2% in simple interest annually. How many years will it take Daniel to earn $1,200 in interest? So here, I start with, do I know my interest? Yes. Daniel's earning $1,200 in interest. Do we know where the original amount, the principal, was? Yes. He used $5,000 to start his investment. Do we know the interest rate? Yes, it's 3.2%. And so we write that as 32 thousandths. Last thing, do we know time? No. We do know it's annually, but we want to know how many years it will take. So we're calculating the time in this case. We're still using the same formula, we just have to substitute and solve a little bit differently. So here I have that $1,200 equals the $5,000 times the 32 thousandths times T. I simplify my multiplication. 5,000 times the 32 thousandths will give me $160. I then divide both sides by $160. So 160 divided by 160 will simplify to 1. And 1,200 divided by 160 will be 7.5. What this means is that Daniel will earn $1,200 in interest over 7.5 years, and that's if no money is deposited or withdrawn on this $5,000. Now, what if we wanted to calculate the rate? We can still do it using the same formula. So say that Lucas invested $280 in a bank account that provided simple interest annually. If Lucas earned $53.76 in interest at the end of 3 years, what interest rate did the account provide? So we know how much interest he earned. We know the original investment, our principal. We are told to figure out the interest rate, so that's unknown, and we're told that this is an annual simple interest over 3 years. So using our formula, we have $53.76 equals $280 times R times 3. I'm going to simplify my right-hand side by multiplying the values together, and that's going to give me 840R. So next, I divide both sides by the $840. 840 divided by 840 simplifies to 1. And then when I do that, I get 64 thousandths. That's the rate as a decimal, but often we report rates as a percent. So when we go from the decimal to the percent, remember we go the other way. We multiply now by 100. So we would say that the account provided Lucas a 6.4% interest rate. Now another calculation we may do with simple interest is to determine the future value. This is the amount that a sum of money will be worth in the future if its earned interest is added to the principal at the end of that time. So instead of pulling out the interest, maybe we continue to accumulate that interest with the original principal. And this is true both for borrowing as well as for investing. So if we think about how would we calculate this, we know the future value will equal the principal plus the interest that is earned. So instead of putting an F, we often will see the letter A for future value equals P plus I. Now, a minute ago, we talked about the formula for finding interest, which was P times R times T. That's helpful because now we look and say this is P plus P times R times T. We can use distribution and say that really this is P times the quantity 1 plus RT. And this formula is what you will most commonly find for the future value with simple interest. Now, why do they use A? I can't say for sure, but my guess is that the A is for the amount in the account in the future. That's how I think about it as to why I say A. So let's look at a few examples. Say that Alexis wants to borrow $25,000 for a new car loan that uses 1.9% simple annual interest. Fairly common situation. If the loan is for 60 months, what will be the total cost she pays for the car? And that's another key thing. Loans are often done in months, 48 months, 60 months, 72 months. They don't like to say years for some reason, but so it's important that we understand how do we go one to the other. So let's look at what we have. We don't have the total cost. That's what we're trying to calculate. So we don't want to just know the interest. We want to know what's it really going to cost overall. So that's unknown right now. We know how much she wants to borrow. That principal is $25,000. We know the interest rate, 1.9%. Not a bad interest rate. So the last thing then is having to calculate the time. Now they tell us time is a simple annual interest, but the time we're given is in months. So we got to think, how do we change months into years to get that annual interest? Well, we know that there's 12 months in 1 year, so we could do 60 divided by 12 and see that there's 5 years. If you're unsure, you can always just start to think through it logically too. 12 months in 1 year, 24 months in 2 years, and just keep going until you get to what you need. So now I have my values and I know what I'm solving for. I can substitute them in and go from there. So I'm going to do 25,000 times the quantity 1 plus 19 thousandths times 5. Now I need to follow my order of operations with my parentheses. I multiply in my parentheses first, then I add my two values. Now I can multiply by the 25,000 to get that the total cost that Janae will pay is $27,375 for the car. So she's paying about $2,400 in taxes, or in interest in this case, but the total is what she needs to think about as it goes to what her monthly payment may be. Now, what if we wanted to calculate for time instead of for the total value? So let's look at how that would work. Micah invests $400 in an account that earns 2.3% simple annual interest. How long will it take Micah to have $800 total in this account? So in other words, how long will it take Micah to double his money? Now, we look at what we have. We know what we want in the account eventually, which is the $800 total. We know where we start, or Micah started with an investment of $400. We know the interest rate is 2.3%. What we don't know is the time. We do know that it's an annual interest, but they write how long, so that tells us time is the unknown, and we're going to calculate it in years. So now we substitute in what we have into the formula. So we're going to put 800 equals 400 times the quantity 1 plus 23 thousandths t. Now there's a couple different ways that we could follow solving this equation, but the most common is to first distribute the $400 back through. This will give me $800 equals $400 plus 9 2/10 t. Now subtract 400 from both sides, so that 400 minus 400 becomes 0. 800 minus 400 will give me $400. Now I divide both sides by 9 2/10. So 9 2/10 divided by 9 2/10 is 1. And that'll give me approximately 43 478 thousandths years. But likely we're going to talk about years either in whole years or in years up to tenths. So we could say that it will take Micah at a 2.3% simple interest rate about 43.5 years to have $800 in the account.